Hi everyone. So my talk's idea starts one day at my company while reviewing our year-end bonuses. This is a monetary compensation based on the accomplishment of certain objectives the company had. So as any good employee, I'll try to find a way to automate this thing. Oh, not working. Oh, okay. To automate this thing, let's find a way to minimize the work I had to do, but maximize the profit I could get from it, obviously. So one of the objectives we had was to get 100% testing coverage in our product. And if we think this for a while, it seems that is an automatable metric. So I had this revelation that testing coverage is measured based on how many lines of your code are being executed when you run your test suite. So if we just delete every line that it's uncovered, that means that because the lines weren't tested or executed, my test will pass anyway. And because the lines don't exist anymore, we will get 100% coverage for free. So yesterday in Nick's talk, we saw how to write programs that write other programs. And today I'll be talking about how to write programs that delete other programs, basically. So to give an idea of what I expect my program to do, let's take this simple example. This is a simple if-else Python code. We will be using Python. And we see here that the else branch of my code is not being executed in my test. It's not covered. So what I would expect from this tool is to, given the source code of the program and the coverage information, to delete the else, the oops, and this is not tested. Just no evidence of it. Or for example, we could have a function that its block can be tested, but it has some unreachable code. In this simple code, we can just remove the last two lines that we will have 100% testing coverage. So to do this kind of tool that involves source code transformation, I use the best tool at the shop to parse source code, that is regular expressions. No, just kidding. Please don't use regular expressions to parse source code. What I used instead was abstract syntax trees, or ASTs. An AST is basically a tree-based data structure designed to represent your source code. In this case, a simple hello world will be translated into a function call node where childs are, for one side, the function name, and for another, the arguments to the print function, that in this case is a binary operation where its children are the hello and the world string. So simple enough, this AST. So just using the Python standard library, it is possible to, when I have this tree that is, it's a syntax tree, but it's a tree essentially. So this means I can walk it and transform it just as we will do with any kind of tree. This simple code that you see here is trying to get pass this print hello world into an AST. Then it will visit each node in the syntax tree, and when it sees some bin operation node, it will hardcode the right part of it to the bang string. So in this case, the print hello world thing will be translated into this hello bang thing. One thing I want to mention is that the Python standard library has an AST module, but it doesn't allow me to convert this transformed AST back into source code again. So for this, I had to use this Google library called Pasta. I wanted to mention it because the maintainers have been extremely supportive. I had to report many issues because what I was doing was apparently kind of strange. So I hit a lot of corner cases related to indentation. But the maintainers helped me a lot and fixed all bugs almost instantly. So this is essentially what I had in my head, and I wrote a project called Magikov that does exactly that. It's free software, it's GPL licensed because we should use more copyleft licenses. And it's not so tiny as I would expect before. I thought it was going to take me a few hours, and it turned out to be way harder, because what I had to do wasn't just removing the else of an if or removing the unreachable code, but I had to deal with more complex AST transformations. For example, I had to deal with side effects in the if test expressions, or I had to deal with the Python yield statement that, because it transforms functions into generator functions, even when it is not tested, even with the yield line is not executed, it will impact on your source code, so I cannot just delete it. One thing I also found that was a bug in the Python coverage library that incorrectly reported my covered code as being uncovered. So when I deleted the line, my code broke because that was actually covered. And apparently this was related to a CPython optimizer machine bug. I have no idea what I did, but eventually I fixed these issues and we got this project. So I think it's time for a demo. Hope this works. Here I have, can you see okay? Or maybe, okay. Here I have a simple Python project I chose just because it has a fast test suite. So I will run its test suite to see, yeah, all tests are passing, just as we would expect. But if we see the report, it has only 46% coverage. That's not good. My boss wouldn't be so happy, but we have Magikov to the rescue. If we, oops, I think I didn't have. Okay, I will. Yeah, I want to avoid any misunderstanding of the tool, so I just ran this and, oh no, Magikov, what did you just do with my code? You messed it up. Yeah, there are a lot of deleted lines. No, this can't be good. But if we run the test suite again, let's wait a few seconds. Oh, all tests are passing. That's good. And if we see the report, then see, whoa, all 40% testing coverage. So I have time for one more demo. So if we think this tool, Magikov, was designed using test-driven development, so it has a pretty good test suite. If we run it, it's all tests are passing, and it's 86% coverage. It's good enough, but not good enough for a 100% testing coverage talk. So let's run it, the tool. Yeah, here I have it. I did some code deletions here, and if we see this, oh, I forgot to run the tool. No. Oh, I didn't run the test, sorry. I have to run the test again. I see the report, and yeah, we just. So, thanks. We just Magikov. So, so as I hope you got by now, this tool wasn't really designed to get a profit to get a profit. It was just an excuse to make a tool. It's useless, but yeah, it has no purpose, but it was really fun to do that. So what I want you to take from this talk is that the world is full of rational, useful, pragmatic software, but that doesn't mean you have to write useful software. This was really fun. I learned a lot of AST manipulation and source code transforming, and even if it's useless, I learned a lot, and it was really fun doing it. So I want you to encourage you to write useless software, more useless software. Thank you very much.